Presentation on design and implementing intelligent lighting control system. Smart lighting is one of the key control components in the smart house intelligent system. Its main task is to provide comfortable conditions for people and reduce their role in managing process in the home. Light sources are the object of control in smart lighting. Currently, there are mainly two types of light sources used in residential and office buildings: LED lamps prevail in residential buildings and fluorescent lamps in office buildings. Intelligent lighting control system use two main methods to reduce energy consumption. The first is to adjust the brightness of light sources. The second is switching off lighting in places where people are not present. Lighting level sensors are most often used to control the brightness of light sources. In the second case, motion or presence sensors are used. The combination of these two methods provides a significant energy-saving effects. In intelligent lighting control system that operates in rooms with dynamic lighting, light sources can be in frequent switching on-off modes. In this case, the transient processes that occur when they are switched on and the reaction of people to switching on the lighting should be taken into account. If the switching on process parameters are correctly selected, people will feel comfortable and the light sources will last longer. However, there are currently no clear recommendations for intelligent dynamic lighting control system that take into account the physical processes in light sources, human physiology, and lighting quality that doesn't cause discomfort to people. The use of fluorescent lamps in lighting system with a control system faces a number of challenges. One of them is the short-term preheating of the lamp electrodes before switching on. Its presence creates a delay before switching on. This should be taken into account when designing intelligent lighting control system. Therefore, experimental studies were carried out to determine the duration of the preheating mode of fluorescent lamp electrodes. The studied lamps were switched on in accordance with the scheme which you can see in this slide. A measuring information system based on a personal computer with an analog to digital converter module was also used to obtain oscillograms of the transient processes. From the oscillograms, the duration of the transient process was determined. In this slide show the measurement results. They are present in the form of a table. As a result of the generalization and processing of this data, their approximation was carried out. An analytical formula was obtained that makes it possible to calculate the transient time of various fluorescent lamps of any power. Taking into account this data, the limiting frequency with which the lamp can be switched on, so that the light from it is perceived by a person as separate flashes is established. It is determined by the formula present in this slide. When using LED luminaries in dynamic mode in an intelligent lighting control system, two main problems arise. The first is their high brightness. The second is that people feel discomfort when the light is switching on. These statements were confirmed by experimental studies. to study the operation of LED sources in lighting systems with an intelligent control system. An experimental lighting system was made. It operates on the basis of Atmega microcontroller and is located in 35 meters long corridor. In this experiment, linear LED lamps were studied. This corridor is situated in our university. The lighting is switched on based on signals from sensors when a person appears in the area of their action. The lights are switched off after a time delay, provided that there are no people in the area of motion detection. This lighting system implements a dynamic lighting control algorithm. When a person is detected by the motion sensor, a signal is sent to the microcontroller. The motion sensor is bidirectional and detects the movement of people both towards and away from the luminary. This makes it possible to determine the direction of human movement. Based on the sensor's signals, the microcontroller switched on the corresponding luminaries. In this slide shows a lighting system with LED lamps which switched on. About the experiment. In a survey of students, 98% of them were negative about the dynamic lighting mode. The main comment was about discomfort when switching on the lamps. Therefore, it was decided to use a smooth switching on the lamps. Of the lamps. However, the time of the smooth switching on remained unknown. The smooth switched on time depends on the following factors. When a person moves along the corridor, the time of the lamp brightness to increase should be no more than the time from the moment when signal is received from the motion sensor to the moment the person approaches the illumination zone, and also not be less than the reaction and adaptation time of the human eye. Since these data are individual for each person, we conducted two field experiment. During the week, a specific soft start time is programmed to each day. It has been set to be the same through the day. For example, in Tuesday it was 1 second, for Wednesday it was 2 seconds, and so on. At the end of the day, the same responders were surveyed about the comfort, the quality of the dynamic lighting system. The questionnaire contained only one question: is it comfortable to walk along the corridor with these lightings? The expected answer was yes or no. A total of 86 students and teachers took part in this survey. The results of the survey are shown in this video. As can be seen from the survey results, the most positive response was given to the switch on time of 3 seconds. However, in the case of rooms where the speed of movement of people will be higher, the switch on time can be reduced to 2 seconds. So, in last slide, summaries the main conclusions. Thank you for your attention.